Hello guys, today I am here to teach you the first chapter of class 11th chemistry. There is some basic concepts of chemistry. So here we start. First of all, I want to know, do you know how to convert degrees Celsius into Kelvin? If no, let me teach you. So what happened that suppose here is Kelvin and we have to convert degree Celsius into Kelvin. So this is degree Celsius, we have to convert degree Celsius into Kelvin. So what we have to do is we have to simply add, suppose this is 0 degree Celsius, so we have to simply add 273.15 and we will get the answer in Kelvin. So suppose we have 15 degrees Celsius, so what we have to do is simply add 273 and we will get this in Kelvin. So how much it is 188 Kelvin. So 15 degrees Celsius is equal to 188 Kelvin. So this is a conversion between degree Celsius and Kelvin. Hope you got it. Now, do you know what is angstrom? Uh, angstrom. So what is angstrom? It is denoted like this, and 1 angstrom is equal to 10 raised power negative 10 meter. This is 10 meter. Okay, so do you know what is nanometer? So 1 nanometer is equal to 10 raised power negative 9 meter. So what is 1 picometer? 1 picometer is equal to 10 raised power negative 12 meter. So these are few conversions. Now back to the main topic. So okay, so now back to the main topic. Do you know what is mole? So mole is very basic and it is very important concept when we talk about the molar chemistry or mole concept. So we define mole. So what is mole? Mole is the amount of substance of a system which contains as many elementary entities as there are atoms in 12 gram of carbon 12. So first of all, we need to know the concept of isotopes. Okay, so isotopes. So what are isotopes? Isotopes are the uh, suppose I can explain with an example. So when we talk about carbon has three isotopes. Okay, one is C12, another one is C13, another one is C14. So these are three isotopes of carbon. So what are isotopes? Isotopes are nothing but these have same atomic number but different in mass number. So what does it mean? It means that number of neutron vary in the isotopes of an element. So in first case you can see that in C12 there are 6 neutron, but in C13 there are 7 neutron, and in C14 there are 8 neutrons are present. So you got the concept of isotope. So similarly, when we talk about hydrogen also have three isotopes: H1, H2, H3. So this is hydrogen, this is deuterium, this is tritium. So these are three isotopes of hydrogen. So now back to our main topic. What is mole? So mole is the amount of substance. When you talk about a mole, it is the substance of a system which contains as many elementary entities as there are atoms in 12 gram of C12 carbon. So C12 carbon is taken here a standard unit of measuring a mole. So when we take 12 gram of C12 of carbon, so this is 1 mole. This amount, the elementary entities in C12 12 gram of carbon is equal to the elementary entities present in any substance. So yeah, so I can give you definition also. Okay, so what is mole? Mole, it is the amount of a substance of a system which contains as many elementary entities as there are atoms in 12 gram of carbon 12. So you see carbon 12 here taken as the standard unit of measurement. So what here we are doing is taking 12 gram of carbon 12 isotope, and the number of atoms present in these 12 gram of carbon 12, when it is equal to the elementary entities present in the substance we are considering, it is equal to 1 mole. So you got the concept. I repeat, it is the amount of a substance of a system which contains as many as elementary entities that are present in uh, 12 gram of carbon 12. So yeah, this is mole. So uh, so one another term here important is what is accuracy and what is precision. So when we talk about chemistry experiments, we are not sure of the value we are expected to get. We get some errors in every experiment. So considering those errors, we have to know about accuracy and precision. So what is accuracy? So in layman terms, we know that accuracy is how close we are to the expected value. So, but in chemistry, accuracy is equal to the difference between mean value and true value. So this is accuracy. So mean value is, you know, that when we do experiment, when we get various values of an experiment, so taking the mean of those values, and true value is the value we are of the particular observation we are considering. So accuracy is mean value minus true value. So true value is the standard value that we should get, that we should get in our experiment. But mean value is what be the experimental values that we get, and we then take the means of those values and we get mean value. Suppose there are x1, x2, x3 readings, and this is 2, this is 2.5, this is 2.6. So mean value will be 2 plus 2.5 plus 2.6 divided by 3, because there are three values. So this will be mean value, and true value will be the value which we are expecting, or the true value of that experiment. So this is accuracy. So now what is precision? In layman term, we call it how precise we are in a particular value. So it is closeness to the actual value. So but in chemistry, precision is equal to individual value minus the arithmetic mean value. So precision is what? Individual value minus arithmetic mean value of that particular experiment. So this is accuracy and precision. Now we will talk about laws of chemical combinations. So there are a few laws of chemical combination according to which a reaction proceeds. So these are few. I will teach you one by one. So first one is law of conservation of masses. Pardon my spelling here. This is okay. So yeah, so law of conservation of mass. So what this law says, that it says that mass of product will be equal to the mass of reactant. So what does it say? It says that mass of product will be equal to mass of reactant reactants. So suppose there is a reaction called A plus B is equal to C plus D. So this is 1 gram, this is 1 gram, this is uh, 0.75 gram, and this is 1.25 gram. So in this particular reaction, when we add mass of reactant, this is 2 gram. So when we add mass of product, this also will be 2 gram. So what does it saying? It's saying that mass of product, that is 2 gram, is will be equal to mass of reactant, that is 2 gram. So this is all about mass of conservation of law of conservation of mass. Okay, so what does this law say? It says that a pure chemical compound always contain same elements combined together in the definite proportion by weight. So for example, I can explain with an example. Suppose there is a reaction, copper plus oxygen gives us 2 copper oxide. In another example, there is CuCO3 gives us CuO plus CO2. In third reaction, we have CuNO3, which give us CuO plus NO2 plus O2. So this is first reaction, this is second reaction, and third reaction. So what I'm trying to convey here is that in all three reactions copper oxide is being formed here, here, and here. In all three copper oxides, the composition of copper and oxygen in the molecule of the compound is the same. Here you can see that one atom of copper and one atom of oxygen. Here also one atom of copper and one atom of oxygen, and here also one atom of copper and one atom of oxygen. So what this law says, that it says that a pure chemical compound always contains same elements combined together in a same definite proportion by weight. Okay, so this is the law of constant composition or law of definite proportion. So as I told, that whenever a pure substance is formed, the ratio of atoms by which that compound is formed is the same in every case. Suppose water is forming in a reaction and water is forming in another reaction. So in both the reactions, the composition of water will be the same. So when water is in pure form, it will always be H2O. So this is what I am trying to convey here. Okay, so this was a law of constant composition. So our third law is law of multiple proportion. So what does this law say? It says that, what does it say? It says that suppose we have a reaction H2 plus O2 giving H2O. Let us balance this equation out. This is O and this will be 2. So yeah, it is balanced. So in another reaction we have H2 plus O2 giving us hydrogen peroxide. Okay, so here this is 4 gram, this will be 32 gram, this will be 36 gram, and in this reaction this is 2 gram, this is 32 gram, and this is 34 gram. So this is first reaction and this is second reaction. So what I'm trying to say here is that here oxygen used in both the reaction will be in ratio 1:1. You can see the mass weight of oxygen here is 32 gram, weight of oxygen here it is 32 gram. So oxygen used in first reaction with respect to oxygen used in second reaction is in 1:1 ratio. Ratio of oxygen used in first reaction with respect to second reaction, 32 gram ratio 32 gram. This will be equal to 1:1, which is a whole number, So yeah, so now I will give you definition. When two elements combine to form two or more than two compounds, here in this case hydrogen and oxygen are combining to form third compound, then the masses of one of the elements which combine with the fixed mass of the other, fixed mass you can see here it is hydrogen, so which combine with the fixed mass of the other are in the simple whole number ratio. Okay, so we have taken here hydrogen as a fixed mass, and we are reacting oxygen with hydrogen in first case, and hydrogen in we are reacting oxygen with hydrogen in second reaction. So what law of multiple proportion say that when two elements, in this case hydrogen and oxygen, combine to form two or more than two compounds, you can see in first reaction water is forming and in second reaction hydrogen peroxide is forming, hydrogen oxide is forming, then the masses of one of the element which combine with a fixed mass of the other, in this case oxygen is combining with fixed mass of other in both direction, then the element which combine with a fixed mass of the other are in the simple whole number ratio. You can see that in both direction oxygen which combining with fixed mass of the other element, the weight of the ratios is in simple whole number ratio. You can see 32 gram of oxygen, 32 gram of oxygen, and it will be 1:1, which is a simple whole number ratio. So this is law of multiple proportion. So fourth law is law of reciprocal proportions. So what does this law says? Focus here. Suppose we have a reaction, sorry, suppose we have a reaction H2 reacting with sulfur giving us H2S, and in second reaction H2 reacting with oxygen giving H2O. And so yeah, now a ratio of sulfur and oxygen. Okay, ratio of sulfur and so first of all, this is first reaction, this is two reaction. This will be 2 gram, this will be 32 gram, this will be 34 gram. And in second reaction, this is 2 gram, this is 16 gram, this will be 18 gram. So ratio of sulfur and oxygen, sulfur is to oxygen, will be 32 ratio 16 by weight. This will be 2 ratio 1, this will be 2 ratio 1. And now in SO2, uh, suppose we have sulfur plus oxygen giving us SO2. Okay, this is third reaction, this is 32, this is 32 gram, and this will be, you can calculate 32 into 32, 64 gram. So what I am trying to say here is that what this law says, that it says when two different elements combine separately with the same weight of the third element, in this case sulfur and oxygen are combining with the fixed weight of third element, then the ratio with which they do so will be the same or some simple multiple of the ratio of in which they are combining with each other. So what I'm trying to say is that when sulfur and oxygen are two elements that are reacting with the same element having same weight in both direction 1 and 2, the ratio in which they are combining with the fixed third element will be the simple whole number ratio with respect to when these two combine with each other. You got it? When sulfur and oxygen will combine with each other in third reaction, so the ratio in which they are doing so will be, it's the simple whole number ratio. So in this case, this is sulfur is to oxygen will be 32 ratio 32 will be 1 is to 1. So 2 is to 1 and 1 is to 1 are the simple whole number, simple multiples of each other. So this is the law of reciprocal. I repeat, when two different elements combine separately with the same weight of a third element, the ratio in which they do so will be the same or some simple multiple of the ratio in which they combine with each other. Okay, so when sulfur and oxygen are combining with the fixed third element, that is hydrogen here in this case, first two reaction. So when we take the ratio of weights of sulfur and oxygen, this will be 2 is to 1. And when they combine with each other in the third reaction, the ratio we are taking here is 32 gram is to 32 gram will be 1 is to 1. So ratio of the first two reaction and third will be simple whole number ratio or some multiple of the ratio taken in first case. So this is law of reciprocal proportion. So fifth and last law is Gay-Lussac's law of combining volumes. So what this law says is that, for example, we have H2 plus O2 giving H2O all in gaseous form. This is gaseous, this is also gaseous, this is also in gaseous form. So this balancing this equation, this is 2H2 plus O2 giving 2H2O. This is two volumes, this is one volume, and this is two volume. So what this particular law says, that it says that under similar conditions of temperature and pressure, whenever gases react together, the volumes of the reacting gases as well as the products, if gases, bear the simple whole number ratio. So when two volumes of gases reacts, this is one volume, I mean to say this is two volumes of hydrogen, this is one volume of hydrogen. So condition for this particular law is the condition should be similar, that is temperature and pressure should be similar. Whenever gases react together, the volume of the reacting gases will be equal to the volume of will be in simple whole number ratio with the volume of product. So this is 2 volume, this is 1 volume, this will be 2 volume. So ratio of all three gases here is, this is 2 ratio 1 ratio 2. Okay, so what this law said, it said that under similar conditions of temperature and pressure, whenever gases react together, the volume of the reacting gases as well as the products, if gases, in this case water is in gaseous form, bear simple whole number ratio. Okay, so volumes bear simple whole number ratio. This is 2 volume 2, 1 volume 1, 2 volume 2. So this is 2 is to 1 is to 2. So this makes a simple whole number ratio. So this is all about these laws. So video will be long, so I'm stopping here. The next part of this chapter I will be covering in next video. I hope you understood something. If you understood something, then like the video, and if you didn't, then you can skip this like button. Okay, thank you.